Hello and welcome to our final lecture of Comp 112. I'm standing here up in my office, a familiar site to many of you, and I thought I might just show you some familiar sites that you may be missing by now. So Wesleyan misses you. The date of recording is March 18th, and we're just right in the evening hours to get, oh, it's almost 5 o'clock. So campus is getting eerily quiet, which is a little bit strange and sad all at the same time. Hopefully things will settle down by the time you're actually watching this video. But I do really love to give this very last lecture, and I really regret that we don't have the chance to actually be here in person, because it's always really exciting for me to see how you've progressed over the course of the semester and to just see your excitement as your projects are really finally coming together. So I certainly hope that this semester has worked out for you and that you are learning how to do all these things despite the fact that we have to do distance learning. I do hope that also you've really enjoyed learning about Python and that you're as excited as I am about continuing on your studying, perhaps, moving into the major or maybe doing a minor or considering some other ways that you might want to continue with your programming. So today's lecture is largely about some ideas of the next steps that you might take and some opportunities that are out there, and also a look at how you might use your skills in the job market, what people are looking for, what other things you might want to learn about. So let's move on over to the slide deck. I'm going to go ahead and share my screen with you. And let's see, share screen, and put up my PowerPoint for today's lecture. Ooh, that down. All right, so your future in computer science. So this is just, once again, a final look at our course calendar. We're progressing along nicely here. So at this point, we should be done with the exam. We should have gotten some preliminary results on your project N, and we should be just about heading into the reading period. You should be working on finishing up your final project. So please do be in touch if you have any questions, comments, problems, issues, and so forth with that. They are due, just as a reminder, on Wednesday, May 13th, 5 p.m. Eastern Standard Time. Please do get them in on time, as I have a very short turnaround time to get your grades out. So it's really important you get them in on time so you can get a grade. All right, so this is an overview of what we're going to talk about in today's lecture. We'll talk about the final projects. Then we'll talk about what's next in computer science, coursework, majors, minors, and certificates, what you could pick. Also, this semester I've added workshops because I've started offering some workshops that could be of interest to you. Sharing and using Python packages. This is a very useful skill and something you might want to look into doing. Python packages for specific fields. Which packages might you want to learn next? Some more popular packages to learn. And finally, some career prospects in Python. And since it made it into the PowerPoint, let me tell you, it's very good, especially for working from home. So again, your final project is due Wednesday, May 13th, 2020, 5 p.m. Please upload your project to Moodle. Your project should include the following items. You should have the working Python script for your project. This is the major component of your final project and the main thing that you're going to be graded on. Make sure you put the heading at the top, and then also there are a series of 6 assessment questions that I would like you to please answer at the top as a comment. What were the 3 goals? If you've updated them, please feel free to incorporate the updated versions. Were the goals met? Yes or no, and to what extent? 3, how does the project illustrate your mastery of Python? So remember that that was one of the reasons why we had it. It is in fact in lieu of a final exam, so this should be somehow illustrating your mastery of Python. What did you learn from doing this project? We get various answers from this. Some students comment on having gone out and learned a new module. Some students comment on learning how to do debugging. Sometimes students learn something about themselves, something about Python, something about their future. What did you find was the biggest challenge while working on your project? This is a really helpful one for us as we teach the course so that we can understand what are the most difficult things for students and try to improve the teaching of the course. And what, if anything, would you like to improve on your project? If you had more time, what would you do next? What what ways maybe did your project fall short of your expectations, or something like that. Okay, finally, you should note any dependencies of your code, such as modules to be installed, what files must pre-exist, and that sort of thing. If you do, in fact, have a project that has dependencies on it, I would recommend that you make an appointment with me to show your project, because I may not have all of the modules installed, and I do not promise to go out and install every possible module that could be of interest to you. So you can just demonstrate over Zoom. All right, great. Let me know if you have any questions or issues about your final project. So what's next? You're just about done with your Python course. Hopefully you've learned a lot of new things and improved your skills. Hopefully doing your project has given you new confidence in your ability to actually write something start to finish. So maybe you've enjoyed the experience. Maybe you're not quite to that point of exhilaration yet, but it is always really thrilling to have that instance when you run your code and for the first time it works with no bugs and does all the things you want it to do. So I do hope you'll all get to that point really soon. And that's the real thrill of it. And that's the challenge and the thing that really drives me on anyways to continue programming, and why I enjoy it so much. That satisfaction of accomplishing something. So maybe you're at that point, or maybe you're just glad to be done with the class. But in any case, you might realize that there's a next step that you may wish to take. So next courses in computer science, if you did decide that you really enjoy this very much, is you may want to move on in computer science. The next logical step in computer science is to take the gateway sequence, which is the 211, 212 computer science 1 and 2 course. That is the next level up, and those count towards the major. Do note that our class does not count towards the CS major, but it is the class that you've needed to take in order to get to the point where you could get into the CS major if you didn't have any programming skills. So you're in the right place, and that's the next thing to take. Maybe you're interested in bioinformatics. I did mention this as a course option at the beginning of the semester for those of you who are having a difficult time getting into the class. What you can do is you can take the second half of the bioinformatics course. So this runs as basically a two-part class. The first half of the semester is the basics of programming. So it essentially covers the same things we cover in the first half of our course, but then they go right into doing bioinformatics after that without doing some of the things that we do in the second half. So what you may wish to do is, if bioinformatics is interesting to you, is you may want to go and take the bioinformatics course, but you register for it as 266 so that you don't have to repeat the beginning part, which you will already know how to do. So if you do want to get admission into the major, as I mentioned, this class, in fact, does not count towards that, but it does get you ready for the 211, 212 sequence. And this is just taken from the online information for the various classes. I believe it's from WestMaps. Actually, this link doesn't really show up very well, but anyways, it's clickable down here. So what you can do is just take a look through here and see what it is the requirements are, and if you think that's something that you want to do. You'll be taking a lot of computer science classes, obviously, and also some math classes. Generally, the major focuses on how this is a science and its relationship to mathematics, and does have some skills, but is definitely very focused more on the theory. So if that's something that you found really interesting, or a direction that you'd really like to go, you might definitely want to check out the major. If you are interested in the math major, then Comp 112, in fact, actually can be used towards your major credits. So again, this is taken from the catalog. Yes, the catalog, not WestMaps. And so what you can do is you can follow the link to get the latest on it. But hopefully this would just give you some pointers as to where you could go next. Definitely you should check it out and make sure that this is all up to date, because I don't update this every single semester. And of course, at this point of registration, they probably have updated it again. So do make sure that you look at the latest information and see if that's something that's interesting for you. So as I mentioned, 112 gives you already 1 credit, 1 course towards your math major. You can, of course, take additional computer science and math classes to go towards that. So definitely consider that. All right, so in addition to that, you may wish to learn other computer science skills. So if you're interested in more like learning how to program, learning about data science, maybe you want to learn another programming language, maybe you're interested in databases, maybe you're interested in geospatial data analysis, maybe data visualization. All these kinds of things are more skills-based things. If you're interested in learning skills-based things, then probably the Quantitative Analysis Center, the QAC, is the next place for you to look. What you should do is you should go to their website and check out some of their offerings. Notice that we have this wonderful class in MATLAB taught by yours truly. So I am in fact teaching that the second half of the current semester, and we do have it on the books again for next year. So if you've missed out this time, you could join up next time. So lots of different things. They do change their offerings from semester to semester. So you want to just check out and see what they have. R, SAS are very popular ones. They do offer a shorter course in Python, which you probably don't really need. And then a lot of these kind of like special interest kinds of things, which tend to be the ones that run at the 200 and 300 level. A lot of these are quarter credit classes. That is, they only run for half a semester. So just be aware of that when you register for them. And because if you're taking it and expecting it to fulfill certain credit requirements, you may get surprised by that. But some of them are full credit, so just watch that. Okay, we also have the data analysis minor. So in order to get the data analysis minor, you need to complete only 5 courses. And guess what? You've already completed 112. So, well, almost. So you're almost there. That means you have only 4 more courses left. So maybe you're thinking about doing the data analysis minor, or just looking through this list, you may notice that you've already taken a bunch of these classes. So just to bring it to your attention that there are a lot of options, it seems like a really easy minor to get. So if it's something that interests you, or perhaps you realize you've taken some of these classes and some of these electives, like maybe you have a major in Earth Environmental, Econ, Government, Physics, QAC, any of these areas, there are lots of electives that can count towards it. It may be worthwhile to just investigate whether or not you're going to be able to complete the data analysis minor. But in fact, some students realize that they're further along in that than they realized and can put that in. Another certificate program of interest is the Certificate in Applied Data Science. This actually requires 7 courses, which is a little bit longer, and it also requires a practicum, which is a kind of a final project, like a thesis basically. But the Comp 112 counts as the Computing Foundations course, so you're already 1/7 of the way of having a certificate in applied data science at least. Again, notice the fact that there are a number of other classes and subject areas that can count towards this. So I would just once again encourage you to consider if this might be something that's interesting for you, and if you're studying in any of these areas, to think about taking some of these other classes and getting the certificate. There's also some additional certificates. We have the Informatics and Modeling certificate, and there are in fact 2 different paths that you could get this, and they focus in different areas. So, and they also have distinct courses that you need to take. So the first path is the Computational Science and Quantitative World Modeling, or CSM. These are the current listings of the requirements for that, and notice the fact that this is Comp 112, Intro to Programming, is going to fulfill one of your requirements. Again, take a look through. There are some classes from a wide variety of subject areas here, and you might be well on your way to getting this certificate. There's also the IGS pathway. This is Integrative Genomic Sciences. So this is more if you're interested in biology and that sort of direction. The other one is more like if you're into, if you like chemistry or physics, so that direction. Well, as you can see from the classes that are going to count towards this. So if you're interested in the genomic sciences, then this is definitely a very good option for you. Notice that Comp 112, once again, is going to count as your introductory computer science course. you'll notice that many of the courses in the upper levels are going to be biology courses, which is not too surprising. I'd also like to call to your attention the CIS, the College of Integrated Sciences. So I am in fact appointed in the CIS, and so this is a really exciting college that we have on campus. It's relatively new, and Professor Shira Mukherjee is the one who is in charge of this. Basically, the CIS allows you to do a sort of like a double major, but it's kind of like design your own major. What you do in order to get a degree in CIS is you will select a major, and then you will also work in another area. And that second area is what will constitute your CIS major or your CIS area. What it allows you to do is have the core courses in one core area. So maybe, maybe it's physics, but maybe you're interested in how different areas juxtapose between each other. So my research, for example, is really quite interdisciplinary. So as you might know, my research lab is in the chemistry department. I got my degree in the MD&B department, and I teach, as you know, in computer science. So I am a perfect fit for CIS. And if I were an undergrad here, I probably would likely be doing the CIS double major. So for example, in my situation, I might choose a chemistry is my first major, and then maybe I would add on additional classes. But the good thing is about the second major is that there's some leeway in terms of what you pick to tailor it towards what it is you want to study. So in my case, it probably would be some computer science, some physics, and some biology, and to bring all of those things together, maybe even some math classes. So what it does is it means that your second major is not quite as stringent as your first major, and it allows you the flexibility to get all of the courses in that you need in order to solve interesting problems that occur at the juxtaposition of a variety of different disciplines. So if that seems like something that you might be interested in, I would definitely encourage you to speak to me about it. Check out the CIS website, and definitely CIS has a wide variety of activities every semester. They have an ice cream social at the beginning. They have events where they offer free pizza. So why not come by and hear more about the CIS? The other thing is it is very much oriented towards research, and you're guaranteed to have a minimum of 1 summer of funded research experience here at Wesleyan. So that's a pretty nice thing to have. So join up. Usually students should be joining in the second semester of their sophomore year, but we have had people who joined up a little bit later in their junior year, so it's not too late. It's still possible to do the CIS major if you are interested and you're a junior, and if you're a freshman, definitely getting involved earlier is always better. So questions, feel free to ask. We also have the ideas minor, which is integrated design, engineering, and applied sciences. This has a lot to do with robotics and constructing things. You've probably noticed the ideas lab. It's near to where some of the TA sessions are held, in the downstairs below our lecture hall. This is a really exciting addition to the offerings here at Wesleyan, and a relatively new one. While this doesn't specifically have anything to do with programming, certainly programming can be involved in engineering and design. And I think now that having taken this class, you are in a very unique position to be able to engage in ideas studies if that's something that's interesting to you. I would also mention the fact that we are now running a series of CIS-sponsored workshops. This is a way for you to foray into a variety of different areas that you may not have time to explore by taking a full class. So I've tried to offer a variety of topics. This is also a relatively new initiative, but in the past 2 semesters, these are a smattering of 3 of the workshops that we've offered. So by this point, we should have in fact offered 6 different workshops. This just gives you an idea of the kinds of things that are available. So I did an introduction to molecular visualization. This is a tool that I use pretty much every day, VMD and PyMol, graphing with MATLAB. So this is a much shorter version of what you would do if you took the MATLAB course with me. We also had getting started with machine learning and Tensorflow, which introduced students to how to actually do some machine learning calculations using an online platform so it's quick and easy to get up and started. We are able to offer these in a wide variety of different areas. So as you know, my work is pretty interdisciplinary, so I have tidbits to share with you on lots of different topics. These are some of the ones we've done. I'll show you some of our upcoming topics. One great thing about it is that you don't have to attend every single workshop. So if you feel like your semester is really busy, but you just want to learn one thing, you're free to stop into just one workshop or a couple of workshops. You're free to cherry pick whichever ones are interesting to you. This is a good way to improve your skills in a targeted area. And oftentimes what I'm doing is also giving you materials for further exploration if this is something that's interesting to you, so that you can go on and find out whatever it is you want to do. Could be useful also if you're planning on doing a research, so you can learn some skill, and it might be useful for you to get into a lab if that's what you're trying to do. Also useful for jobs, so if you need to pick up some skills to put on your resume, this is a quick way to get up and started with some of those skills to check those boxes. So what you should do is you should watch for postings in the science buildings. So we usually post pretty heavily, and maybe you recognize some of these posters. The other thing you're welcome to do is email Maureen Snow, msnow@wesleyan.edu, and ask her to be added to the mailing list for the CIS workshops. And finally, let us know what workshops you would like to see. If there's a particular skill that you think fits into this area or something you think I might know about, definitely feel free to ask me for a workshop on it. These are some of our ideas for upcoming workshops in the CIS. So we're working with Raspberry Pi, which is one that I hope to work into a workshop that also involves some work with the ideas. So maybe it would be a two-part where you learn how to program the Raspberry Pi using Python. And then the next thing you could do is so some of the things you can do are blink lights, do robotics, move around, respond to sensors and this kind of thing. So what we were thinking about doing is designing a Raspberry Pi that actually does something interesting, like blink some lights, just as a simple example. So you can blink patterns to look interesting. So you can make like those little signs where you would have the lights spell something out or something like that. Just something kind of fun and exciting to do, and then to house that into something. So I was thinking a lighthouse. So that's our current proposal for the project on that. Unfortunately, with the coronavirus and so forth, this has been delayed for when we can have an in-person meeting. So we're not running that this semester, but do watch for that in upcoming times. So if you're interested in robotics, this is a great way to get started, and Raspberry Pi is extremely powerful. Animated graphics with Python, I'm actually planning to run this. So some of you may have actually attended this by the time you're seeing this, but this will probably have something to do with some of your final projects. The students always ask me questions about that. So I'm hoping I can extend what we learn in Python outside of the classroom into the workshops to touch upon topics that are maybe not core to what it is that we learn, but things that would be fun and or useful for you. Do let us know. So now you're expert programmers in Python. Let us know what else you would hope to learn about when you are studying Python. Finally, another one of our upcoming lectures is going to be parallel computing. So again, that was something that requires students to be on campus to log into the cluster and get the accounts up. It is possible to do it off-site, but a little bit difficult to get up and running. So we'll be offering this hopefully next fall. So do keep your eyes open if you're interested in parallel computing and using supercomputers. This would be a great workshop for you to look at. So that brings us to a couple of things that I'd like to show you how to actually do. So I'd like to teach you how to share and use packages, how to share what you wrote, and how to get other people's programs, which are two things that are very important for working in the real world using Python. So there is a repository called PyPI, see, PyPI, like this. And this is where the Python packages get stored. Now, you might have actually encountered using PyPI because you might have in fact actually used some packages for your project. So this is where you can go to find great Python packages, which is the Python package repository. You can search this and then find and download packages. I'd also mention the fact that they're written by a variety of different people, so the quality of the packages that you find here may have some variation. That's why there's certain things belong to the core part of the Python package, and then some of these others are like add-ons that are constructed by the Python user community, like you. Okay, so you may want to learn a little bit more about that. So I'm not going to sit here and play all the video links for you in a video. So please do feel free to go ahead and check out these links if any of these things are interesting to you to find out more about the packages. So I just wanted to give you a quick starter on how to actually create the Python packages and hopefully give you the idea that, yeah, this is maybe challenging, but it's not impossible for you to do this. And I've actually had some students who went ahead and did start to create some Python packages. This is really great if you're thinking about applying for jobs that require programming, or if you'd like to have something to showcase when you go on an interview. You can say, look at this, I made my own Python package. All right, so this is what you need to do. There's going to be a special directory structure that you'll need to set up, which now you know about from file.io and when we learned about the directory trees. You're going to need to create a file called setup.py, and that is going to tell the setup tools info about your package. Samples over here. Create the readme.md page, and then you'll need to set up your copyright notice. So that is, you'll have to decide, you know, are you distributing this for free? Can people sell it or not? And so forth. You can find sample copyright notices online, and of course, by simply just downloading one of these from the PyPI and reading what other people have written for their copyright notices and what the license is. Then you're going to need to generate the distribution package, upload your package to Python package index with Twine, and then other people will be able to install your package using pip off of the PyPI repository. So then once the package is installed, other users will import your package and start using it, just like you may have been using other people's packages. So this just gives you an idea of what these scripts are going to look like that you need to make. And so you can more or less just follow these examples over here. And here I give you even a sample copyright that you may want to add into your Python script. So that brings us to working with packages. So this here is a little tutorial on how to install packages. So the essence of it is what you need to do is you need to get a tool called pipt, which is going to allow you to download tools from PyPI. And so once you've got that, then it's pretty straightforward to move ahead and install the software that you want to do. If you work with Pygame or maybe Matplotlib or any of the other add-ons, then you've probably already been working with pip, and so this will be a familiar task for you. You can watch this tutorial right here, and again, I'm not going to play all the links, but do feel free to go there. All right, so maybe you heard about GitHub. This is another thing that you should definitely be aware of. This is a platform for the development of packages. So while PyPI is mainly for distributing completed packages, GitHub is more like a platform for the development of programs. This is for things that aren't quite yet done yet, or that you're looking to expand upon, or that are an ongoing project where you're adding things like new features and so forth. So you've probably heard of it before, and it's pretty simple to use it. What it allows you to do is to upload your code there and work on it. It also allows you to go on there and to look for other people's projects to see what other things maybe people are working on that you would be able to contribute. This is a great way to get experience working with programming. Suppose you have free time on your hands because you're stuck home with coronavirus, or maybe it's the summer break and you have no work to do, no textbooks to read, no homework is due. What should you do with all this spare time? Well, you could always build up your coding skills by going to GitHub and seeing what project you might be able to contribute to, and join in and start contributing to a project. There's all kinds of things you can work on. There are many different projects that need doing and that need coders to do it. It's a way for people to collaborate and all put their great ideas together. Python packages with applications to specific fields of interest. So students in this class arrive with a wide variety of backgrounds. And because of that, there are probably lots of different reasons why you have taken this class. So What I would like to do is suggest to you some other things that may be packages of interest to you based on what your area of interest is. So maybe you're a musician, maybe you want to be able to play music, or maybe you just like music and you want to be able to play sound. So one of the things you can do is you can use Pygame in order to play sounds. This is done by downloading and installing Pygame, and then this video here will give you some instructions on how you can actually do that. Maybe you're interested in gaming itself. Maybe you want to make something that's a little bit more sophisticated than just working with turtles, which is totally understandable because turtles is, after all, kind of a rudimentary platform in order to be doing this. So what I would recommend is that if you're interested in that, to check out Pygame. This is pretty much the platform that people use to develop Python games. There are some others as well. This will give you an example of how to install Pygame and get started with it. I've in fact actually done this. It took a bit of doing, but it's not too bad. And you can get up and be working with animations pretty quickly with this. So it's fun and a very popular way to get working with that. All right, Tensorflow is another thing you might have heard of, and as I mentioned, I gave a workshop on this. Tensorflow is an artificial intelligence and deep learning tool. This is using machine learning to do tasks such as identify what something is in an image. It can also be used for a wide variety of other things, and in fact, we're actually applying it in my research to do things like identifying how you could allosterically regulate a protein. So there's many things you could do with it. And basically it's working on the principle of neural nets. So if you've studied neural networks at all, or maybe you've talked about the analog to that in biology, you may have an interest in learning how to use TensorFlow. It basically sits on top of the scikit-learn, so you should learn these things sequentially. Maybe you're interested in parsing web pages. Some students are interested in this because they're interested in, for example, collecting information about stocks. So, or maybe you're just interested in it because there is news stories that get posted and you want to go through and do something with those web pages. Maybe you want to, pull out some information. I actually had a former student who took this class who now has started a company with one of his friends, and they are parsing social media and using that to predict how the stock market will change. And apparently their company is doing really well. So it is something that's useful and interesting. So if you're going to be parsing web pages, you would consider using Beautiful Soup. Here is a video on how to get started. Maybe you're interested in econ, or maybe you just want to get rich off of predicting stock prices. So this would be for you. So this right here is a basic video on how to write some Python code in order to predict some stock prices. There is some code out there that is specifically designed for this. So as you might imagine, these are going to be some libraries that are being used. What we can see from this snippet of code right here is that they're using NumPy, which is the next level up from importing math. NumPy is able to do more sophisticated things like having vectors and matrices in it. Scikit-learn is the underlying program of TensorFlow, which is the state-of-the-art machine learning tool, but Scikit-learn has a lot of the real workhorse programs in it that are going to do that. And Matplotlib, some of you have encountered in your project, is going to graph data. Interfacing with the real world. So this is along the idea of the ideas minor. If you're interested in that, maybe you want to just get started with some programming that involves robotics. You can do this on your own, and I would definitely recommend using Raspberry Pi projects. So I've actually recently gotten this little book here, 20 Raspberry Pi projects. I'll mention it is really geared towards kids, but the great thing is that it's very simple to follow, and it shows you photographs of all of the electric diagrams, because I don't read the electronic diagrams. It's been a really long time since I took electricity classes, so I don't remember all the symbols, but here you don't have to. And so this right here is a photograph from my living room about a year or so ago when I was getting started with using the Raspberry Pi. So this little thing right in here, this green credit card size board, that is a tiny computer, which is a little bit bigger than a credit card. amazing. You can actually run a whole computer off of this, and it runs the operating system called Raspbian, and you can do all kinds of things with it, like connect to the web, surf, check your email. I mean, basically all the things you do with your laptop, you can do with this little tiny computer. And it's also quite a bit cheaper, so a Raspberry Pi, depending on which model you get, will run you anything from about $12, which is the Raspberry Pi Zero, the simplest one that doesn't connect online, all the way up to the latest, which is the Raspberry Pi B+, which is what you are looking at here. This is hooked up to a bunch of peripherals such as my screen and a mouse. And here we have the interface with electronics. I told you that you can interface this with doing electronic processes. So like robotics, you can have, you know, wheels, or you can have motors, you can have sensors for infrared light, or for all kinds of things. This right here is interfacing with just this little console right here. And I have completed Hello World using the Raspberry Pi, and I can adjust the brightness of this using the rheostat. And when I first did it, I did not turn the rheostat to the correct level, and I thought I failed, but actually it worked quite well once I learned to adjust the brightness. So anyways, I would recommend this. This right here is an example of how you can order such a kit off of Amazon.com. So you can see that for $69.99 at this time, you get the Raspberry Pi and you get some memory, and they're giving you also a case, and some other peripheral accessories are going to be in here. Some of the kits come with more things than others, and usually when they're more expensive than this, it's for the electronic components. So if you already have those things like LED lights and keyboards and this little display here, it might be cheaper to buy it as a kit, but kind of depends what it is you would like to do. It's a lot of fun. You'll be doing these kinds of things and ideas. One of the projects that they do is learn how to program the Raspberry Pi, so you can make the Pi respond to what it discovers in the real world and make it move things. So I actually had a student who made a robot that drove around my office, and when it hit a wall, it would change direction and drive somewhere else. So it was pretty cool. That was definitely an over-the-top project. Really exciting area. If you're interested in ideas, I highly recommend buying a Raspberry Pi and playing around with it. If you'll be here next year, as long as you're not sadly graduating this year, and you'll be with us next fall, do watch out for a workshop, because I'm hoping to run a workshop that interfaces between programming using the Raspberry Pi and actually building things to house it, as I mentioned before. Here's just actually a kind of a messy picture of my old house of my Raspberry Pi, just to give you a sense of its size and how it's all connected up. So this is my Raspberry Pi right here, and there we have it. And these are the different things that I have connected to it and the various components that I hooked up via the USB. This just gives you an idea of how you can use some code to work controllers off of, so basically it's controlling that LCD panel from the Python code. So this is what it looks like. And I know this photo isn't super great. It's a snapshot of my screen, but I'll put the code over here. So you'll basically recognize this as looking a lot like object-oriented programming, which is a lot of what people do, right? But you can understand some of these things, right? Import, you know how to do this. So they're importing a library that somebody else made with as GPIO. So this is going to manage the input and output pins that are going to be on the Raspberry Pi. That's how it works. So if you take a look maybe on this one here, it's maybe a little bit difficult to see, but these are all a series of pins that are on here. And what you do is you just hook the wires to those pins, and then you hook the wire to something else. So the way that you control it is basically you're going to be electrifying various pins from your code. So here what we're doing is we're doing some object-oriented programming. So you're assigning some values to the attributes in this object. And here what we're going to be doing is, okay, so I made a variable version down here. This will be fed into the LCD object as the variables read in for initialization. Yeah, So this is basically two different ways to do the same thing. And then you're going to have defining the LCD size and so forth over here. If you're interested in taking a closer look at this, because this is actually not showing the whole code, but the beginning of it, the link for this is shown right here, so you can go and see that. This is a little bit cleaner of a version of it. That's also featuring some of the other bits of the code here. So we have our main loop here. We have while true, so you understand what that means now. You're going to increment the number and then print it to the LCD number. So what this one is going to do is this is going to count up to a particular number and basically show that counting going on the LCD screen. So you could just do the opposite, and you could have countdown on the LCD screen. And here we are actually writing to the LCD screen. So you see this is LCD.write string. So we recognize this is a method of the object LCD. So that is an example of a class which we presumably imported in one of these imports, probably GPIO. Actually, it's probably this one right here from rplcd.gpio import character LCD. Yeah, so that's where that would come from. So what you do is you basically have to investigate which libraries it is that you need, and then those libraries are basically going to be Python scripts that you import, which will contain the objects and then which will contain the classes, and then you make instances of those objects to do something. So here then we're going to use the time to sleep in between, right? And so your countdown will happen inside of this while true loop, and then when it's done, it closes the LCD and runs a cleanup method in order to reset the LCD screen. So even though you haven't done this before, you can probably really understand a lot of what's going on here from what we've already done in this class. It's a lot of fun. I definitely recommend playing around with the Raspberry Pi. Okay, so another thing that we have here is some popular packages and so forth to learn. So some packages that could be useful to learn, maybe you've learned some of these or at least heard of them, are listed here. So tkinter, this stands for Toolkit Interface. So what this can be used for is to make clickable windows. This is like a next level up off of the turtles, which works, but this is a little bit nicer and a little bit cleaner, and the graphics look a little bit better. There is a higher learning curve to getting into tkinter, but anyways, could be something that's interesting to you. Jupyter Notebooks is also a popular tool to use. Basically, what it does is it actually allows you to run Python inside of a document. So say you wanted to teach somebody how to run a new script. So this came up in my lab. We're instructing students on what to do, and then they need to do something, or they need to understand what's happening in a certain step. So there's some text in between. And then there's a window where you can actually execute the Python code that resides inside of that document. So it's used for teaching and documentation, and it's a popular interface. You can use it with not only with Python, but also it's able to run other code as well. So you may have seen it in another context. Web development is another popular thing that people are interested in. Django would be the thing that you could be interested in learning how to do. And Beautiful Soup, as I mentioned before, is useful for parsing the web pages. Some more interesting things you may want to learn. Pygame, which you use for video game development, which we saw examples of before. Maybe you're interested in science and data analysis. Maybe you're taking some of those minors related to this area. Some of the things you want to move forward with learning are NumPy, mathematical operations in Python. This is really great for matrices, and it has a lot of the functionality that MATLAB has. Pandas is going to be for manipulating data sets, and what it stands for is it stands for panel analysis. Pandas sits on top of NumPy, and Pandas is going to allow you to do large-scale data analysis fairly quickly. Some of the things it's going to do is, for example, automatically calculate some statistical values. So if you're interested in, say, like taking the average, who wants to sit around and write a function to calculate the average? It's already in there. So you can use that. It's got a variety of other useful functionalities as well, and it's pretty much a foundation for doing data manipulation. So I'd recommend learning that if you're interested in going on while doing Python programming. Matplotlib is used for making graphs in 2D and 3D. Taken together, these things often are considered to replicate a lot of what MATLAB does. Now, as students, you can get MATLAB for free. However, once you leave the academic world, MATLAB is reasonably expensive, and so some people prefer to work with the Python version of it. Others prefer to work with MATLAB, and there are many companies that use MATLAB exclusively for their data analysis because of the packages that are available. Maybe you're interested in machine learning and artificial intelligence. So scikit-learn is the base level machine learning package that you'd want to learn next. You'll need to definitely get through NumPy and pandas before you tackle scikit-learn because it uses many of the things that are presented in there. Also, of course, object-oriented programming is something that all of you have now mastered and is important for using this because that is a concept that is used throughout. Tensorflow then sits on top of the scikit-learn, so it's a high-level programming language for doing machine learning. So for example, actually making neural networks or perhaps Markov models or any other kind of machine learning tool, and that's the one that does that. Molecular visualization, maybe you're interested in looking at molecules, maybe you're an MPNV major, biology major, interested in proteins. So PyMol, in fact, actually is a Python interpreter, and that's why it's called PyMol. So it allows you to view 3D structures of proteins, DNA, RNA, and other macromolecules, and it's going to render the images of the molecules. However, you can also write Python code inside of it, and it can actually execute Python code. This enables you to then write Python scripts that are going to analyze the molecules and change how they are visualized. If you're interested in data science, then these are some of the things that you should be interested in learning. So we've actually come across a number of these. So again, you want to start off with NumPy, which isn't even shown here. And below that would be object-oriented programming. So you're basically going to assume that you already know how to do those things. Then you go on to learn about pandas, the Python data table analysis. Then you would move to scikit-learn, and so in parallel you could perhaps learn matplotlib and or Seaborn. So Seaborn is a higher sophisticated version of matplotlib for graphing, and then after scikit-learn you can also move forward to learn the Tensorflow, which, as I mentioned, is probably the state-of-the-art for machine learning. So after telling you all these things, is it really worth it in order to spend all your time learning these new skills? Should I continue studying and learning about Python? Why or why not? Are there any jobs out there for people who program in Python? Well, as a matter of fact, there's an awful lot of things you can do with Python packages. And in fact, there are a number of top companies that are using Python. Right now, a former lab member of mine who learned how to program using Python is now at Google. You may recognize a number of these other companies: Dropbox, Instagram, Amazon, NASA, Firefox, Yahoo Maps, and Twitter, Facebook, Reddit, and many others. So there are a wide variety of companies that are using Python, and so you may be interested in looking for jobs or internships at these places. If you're not staying here for summer research, or perhaps you wished you had gotten in to do summer research and didn't get in this time, didn't get a scholarship, one of the things you should definitely look into is doing an internship at one of these companies, and that can be very helpful for getting a job. These are some of the things that people like you to be able to do if you're going to work in that. So these are some of the different job opportunities. So for example, Python developer, which would be actually writing the code, research analyst. So I might fall in this category, or perhaps a data scientist or data analyst, people who use existing code to do things with it. We also do some software development in my lab. So, and actually now that we're having an increasing number of computer science students in my lab, that is something that we've been doing more of, especially since we've invented some new methods for studying our molecules. So being able to write software from scratch is great, and also doing some development engineering would be another area where you might look for some work. So What skills do data scientists need? So this is taken from this article that's cited down here. So you can certainly go and read the article for yourself to see, if you agree with what they're saying here. But what we can see is that according to this article, 53% of all data scientists need to know how to program in Python. So isn't that great? You are now above approximately half of your competitors because you know how to program in Python. These are some other things that people are asked to know how to do based on this group that was polled. So R is another one. You can take classes on that over in the QAC, but look at this. This is great. So that's the only one that's really eclipsing it in terms of popularity. So where's the job market headed for Python? This is an example of a graph showing you some of the job trends from Indeed.com. And so this is discussed also in this video. So you can go ahead and watch that video if you're interested in finding out more about this. But basically what we see here is a series of different programming languages. And look at this. Python is at the top of the charts here. It's predicted to have the highest growth rate of all and seems to have over time been growing the most rapidly. So Python is in fact actually one of the newer programming languages that's available. So it's a little bit surprising that it's done so well, but it does many things that it does quite well and is a really great top level language to know. So definitely something that you could put to work if you decided you wanted to have a career programming in Python. So what does it take to actually land a job using Python? So this video talks about this person's perspectives on getting that first job. And so here are top 10 Python developer skills that you need to know. So some of these things are going to be familiar to you. Object-oriented concepts, we did that. And so some of these other things we've been talking about as to skills that you may wish to acquire is your next step. How to acquire them? Well, I would recommend just going to Amazon and Googling it and getting yourself a good book that will start to finish tell you about these skills. You can also learn from tutorials online, although sometimes it's difficult to know what set of tasks you should know how to be able to do, whereas if you buy a book, you do have the benefit of it having been peer-reviewed and should have some authority in terms of what it actually covers and whether or not what they're telling you is actually correct, whereas downloading some tutorials from who knows where off the web may not have that same level of confidence in information that you get. But that's certainly up to you, and there's definitely a place for watching videos and just, seeing what tutorials you can find online to gain the skills that you need. So then, in summary, this is what we've talked about today. We talked about your final projects, and I reminded you when they're due, which is going to be on May 13th. So do make sure you finish up your final projects and turn them in by 5 o'clock. I suggested some courses that you may want to take. Coursework, majors, minor certificates, workshops, other things that you might do as your next step in your computer science career. Doesn't necessarily mean you need to be a CS major, but maybe you just want to involve computer science in whatever your career plan is. We talked about how to share and use Python packages with one another. So that would be using the PyPI repository and also using GitHub. Another thing we talked about was the Python packages for some specific fields. There are a number of packages that are particular to different areas of interest. And so I showed you some that may be of particular interest to you. And certainly you should go and explore what other packages are out there. We also talked about popular packages to learn, such as Pygame and others. So those may also be something that are useful for you. And finally, we finished out with looking at the career perspectives for people who know how to program in Python. While I don't want to give you the false hope that you're ready to walk into a top level job right now, certainly you are poised to go off and learn the additional skills that you need to do. You have a good solid foundation at this point, and so if you do want to go in this direction, I would encourage you to follow up on some of these areas of interest, to pick some skills and work on building those up. Come to our workshops, go to the QAC classes, and get more skills so that you'll be able to get jobs that are interesting to you, or even just use it for doing service work or whatever you would like. Okay, so looking ahead, the most important thing then is, of course, to complete your final projects. That should be your main focus for the remaining days of the semester. So with that, I would like to just thank you for an anticipated great semester together. I know that this semester is going to be kind of crazy and something totally different than what we usually have. I regret that we didn't have as much time to spend together as we had figured we would from the beginning of the semester, but I am really excited about what projects I've seen you propose to do, and also I saw a lot of really good things on exam one, which at the time of recording is the only exam we've had. So keeping all those things in mind, I have high hopes that you're all going to do wonderful despite all the things that are working against us. I wish you all the very best, and certainly I hope you'll keep in touch with me to tell me about your adventures with coding with Python and other things. If at any time there is anything I can help you with or advise you on, or just give you some advice on programming in Python or anything else I might know about, I do hope you'll stay in touch. And I look forward to seeing you in the final exams week online to see the rest of your projects and to actually receive your projects and be happy with you to celebrate what you've achieved this semester. All right, with that, I'm going to sign off, and I'll be seeing you online. Bye-bye.